Hi, my name is Kelly Pascual. I am with the class D01, section D01. And today we're going to be talking about the dental x-ray and the tube head. So in the dental x-ray, there's three main components. There is the control panel, the extension arm, and the tube head. The control panel is usually located outside the operatory. So that's where you go outside and where you can take the x-ray so that you're not exposed to the radiation yourself. There's the extension arm, which is located inside the operatory, and that's what is connected to the tube head and helps position wherever you need the tube head to be positioned at. It also runs electrical wires to the tube head and to the control panel to help send signals to what needs to be taken. So over here is our tube head, and this is what we use to actually take the dental x-rays. And so, like, let's say this is our patient over here, Mr. Snoopy. We would put a sensor into his mouth. If we had the extension arm, we would locate it. We would rotate it to wherever it needed to be rotated at, and then adjust our PID, which is our positioning indicating device, to wherever it would be needed to be positioned at. If we're doing molars, more towards the back of the mouth, premolars a little bit more forward, and then we would go outside and we would take our picture, or we would go outside to the control panel, select the settings, and to take our x-ray. So now inside our dental tube head, now we have over here inside of our tube head, we can open it up, and this is what it would look like. So the tube head, it would be this whole device right here, and it is a tightly sealed heavy metal housing containing the x-ray tube that makes the dental x-rays. And then what surrounds it is the metal housing that is an x-ray vacuum tube and transformers that protects the tube and the ground voltage components. And then on the outside, like I was stating earlier, is our PID, also known as our position indicating device. It is a lead line, and it aims and shapes the x-ray beams, and the x-ray beams exit out the tube head at the port right here. And then now we'll go open the inside of our box again. So this is the inside of our tube head. As you can see, all the yellow around the inside the tube head is our insulating oil. And our insulating oil surrounds the x-ray vacuum and the transformers to prevent any overheating. So as you can see, all inside of our tube. And then next is our tube head seal, which is down here, over here. So our tube head seal permits the x-ray to exit from the tube head. It seals in the oil and helps filter the x-ray beam. And as you can see, over the seal is our illuminating disc, which helps filter out non-penetrating longer wavelengths x-rays. And under that is our lead collimator, which restricts size of the x-ray beams. Okay, so next we have the x-ray vacuum tube, which is this right here, this whole bottle right here, and it is also known as the heart of the x-ray. It is a lead glass tube containing cathodones and anodones. And then right here, this little hole right here is called the beryllium window. It is an unlidded glass window where small numbers of x-rays exit through the vacuum tube through the window. And then we have our filament circuits, which provides power to the tungsten filament and the cathodone, which are these right here. As you can see over here, our yellow string, and it's hooked up over here to our transformers, which our transformers can either provide higher voltage or lower voltage. And then after that, we have the cathodones. They help supply the electrons needed to help generate the x-rays, and our negative electrons. And we have the tungsten filament, which, if you can see, it's over here on the side right here, and that helps produce the electrons when needed, and when heated up, it can help produce the electron cloud. And then we have our myelodome cup, which focuses the electrons into a narrow beam towards the tungsten target. And we have our anodones, Oh, and this is our cup right here. And then we have our anodes, which converts the electrons into X-ray photons, and they are positive electrons. And the tungsten target, which serves as the focal spot to convert the X-rays into photons. And then lastly, we have our copper stem, which dissipates the heat away from the tungsten target. And over here is the copper stem. And then now we're just going to go over how the X-ray, how they're produced. How it all works to produce the dental X-ray is the electricity from that wall outlet supplies the power to turn on the X-ray where the current travels in the extension arm. The current is directed to the filament circuit and step-down transformer inside the tube head and reduces the voltage. The filament circuit heats the tungsten filament for the cathode part of the head, causing an electron cloud to form around the filament surface. Then when you push down the exposure button, it causes a high voltage circuit to activate the myelodome cup, and the cathode directs the electron to the tungsten target in the anodone. The electron travels from the cathodes to the anodes, and the heat that is being produced causes the X-ray to carry away from the copper stem and be absorbed by the insulating oil. The X-ray travels through the unleaded glass window to the tube head and aluminum disc. Lastly, the X-ray beam is confined by the lead collimator and travels down to the PID opening. Thank you so much for watching my video, and I hope you enjoy.